All right, ATS 3.0 digital TV is changing yet again. Or ATS 3.0 is also known as Next Gen TV. What is it and what does it get us? Well, TV broadcast has came a long way from the NTSC days, which served us pretty much from the 1950s all the way up to the 2000s. NTSC, with its sync signal down there and color burst, was basically an analog way of sending a video signal that would then be recreated back on that big CRT tube sitting in your living room there. And a spectrum display of what NTSC looked like. It occupied about 6 megahertz of bandwidth, had a video carrier, which was AM. It also had a color carrier, which used, look at that, I and Q. See, the old is new again. And it also had an audio carrier, which was done in FM. Very cool. And then at the start of 2000s, they switched the whole ball game to ATSC 1.0. It's still an analog transmission, but what they are transmitting is essentially digital bits from the video compression stream. And the modulation they used was called 8VSB, this digital sideband. In a way, fancy single sideband type scheme. So basically we had an analog signal that only had 8 discrete values, right? And this would be the baseband signal shown here. It occupies about 6 megahertz at baseband. Then they simply multiply it up to a carrier. Now if they simply transmitted that would occupy 12 megahertz of bandwidth. But the FCC said it has to occupy 6. So what they did is they filter off one of the sidebands, also throw in a pilot carrier to help the receiver coherently demodulate the signal. But as you can see, yes, it's a digital modulation, but it is still essentially an amplitude modulation. You can think of this step signal here as the voice, and we're simply modulating that up to a carrier. And then the job of the receiver, which is always the difficult part, is to then detect all those 8 levels, and based on the 8 levels, determine the bit level. Now, that all sounds well and good, but the reality is in a receiver, you're going to have multipath, and basically many of these time domain signals are going to come into the receiver at different delays, and it is a significant problem for the receiver to fix that. And early ATS tuners were pretty bad. I do have to say the modern chips have gotten quite good, thanks to using fancy things like LMS equalizers and adaptive cancelers. We won't get into any of that because that's way beyond the scope of this channel. But needless to say, ATS 1.0 has served us for still to this day and is a good standard. The compression ATS 1.0 used is kind of an oldie, but that's what was around at the time, and that's MPEG-2. We've come a long way with modern compression schemes that ATS 3.0 is going to utilize. And the next slide here is going to show you the goal of what they want to do with ATS 3.0. So basically, the broadcasters, they no longer want to be one way. They want to know what you're listening to, what you're watching, and then feed that data back to the TV tower or the broadcast network by your local internet, so they can get a real-time sense of what you're watching and what you watch. And then when commercials come on, they can give you ad-specific content for your interests. So this is a grand scheme of what they're thinking. They're gonna stream thousands, or not thousands, but 20 video streams if they want, or they could do data streams all on the same tower in the same frequency. So they have a lot of grand schemes of what they want, but the new part about this is they want feedback. And in a way, this is nothing new, right? This is what your Netflix or your Amazon Prime does. They see what you watch, and then they throw up different similar shows based on what you watch. There's a whole algorithm to this, and basically the broadcast industry, the over-the-air broadcast industry, wants to get into that, and I guess we can't blame them. And as Gerald says here, there's multiple physical layers for the single frequency for ATS 3.0. So this has all the, ATS committee folks all excited, and all the Bobbies and Sallys are talking about it, and they got grandiose schemes of how this is going to be the next thing and help America. But as anyone really knows, all this is really just about money, specifically more advertising. The more advertising you can do, the more cash the TV networks do. So that should be no shocker there. So ATS 3.0 is going to not use 8VSB, it's going to use OFDM. What does that stand for? That stands for Orthogonal Frequency Division Multiple Access. Yeah, it's a mouthful. I do a video on OFDM, so go watch that if you really want to know what it is and what are its advantages. And basically, we got a whole bunch of digital streams. We're going to take the IFFT, add them all up, send them out the transmitter, and then the receiver is going to take them all, do the FFT, and get the bits back. Sound pretty straightforward? All right. A more simplified idea is we're going to transmit many parallel bit streams, different sine waves essentially, at the same time, and we're going to add them all up and send them out the transmitter. Now, what's the advantage of doing this? The main advantage is to battle multipath by having these parallel bit streams transition at a much slower rate. Allows us to have lower symbol speeds and can deal with multipath. Now, of course, all of this does have its problems, and the main problem is on the transmitter side, and that is something known as PAR, power to average ratio. And what do I mean by that? Well, when you take many sine waves and add them all up, what does that look like in time? Well, it looks like a signal with high peaks, but the average signal is much lower. And sometimes the ratio of the peak pulse or signal to the average signal could be on the order of 12, 13 dB. So what this means for the transmitter amplifier is it has to now be operating in a highly linear range and will effectively mean less transmit power. So that's a problem with OFDM. It's always been a problem for cell phones and everything else, and it's going to be a particular problem for the broadcast industry where they're trying to achieve 50 kilowatts or less, so serious power. The amplifier companies, Rohde & Schwarz, they have some tricks up their sleeve to help all this, but that is the problem, one of the significant problems with OFDM. It helps with multipath, but the problem is mainly for the amplifier. You have to work in the extreme linear range. When you do FM or PM, you can literally operate the amplifier in compression because all the information is not in the amplitude, but the phase. So that's an advantage of FM broadcast. They can operate those amplifiers in compression. They'll have to put filters after it to suppress all the spectral junk, but they can get the most power out of that amplifier because the content is not in the amplitude of the carrier, but the phase. That is not the case for OFDM. So I figured I'd show you folks what's ATS 3, all the grand schemes of what they plan on doing. And again, that way the TV companies can make some more money. So here's a application of how OFDM is used to broadcast new digital TV. Well, that's in for now. Go ahead and study your OFDM signals, and maybe you can prevent and be a part of the new TV digital revolution. Bye bye.